In this second part of chemical reactions of amines, I am going to explain Hinsberg's test, electrophilic substitution reactions of aniline. So, and along with this chemical reactions of amine, I am going to explain benzene diazonium salt also. So, before starting the lecture, please subscribe to the channel if you are new to the channel, and share to your friends. Thank you. Okay, let's start. Hinsberg's test. Hinsberg's test is a test to differentiate primary, secondary and tertiary amine. In this reaction, we take Hinsberg's reagent, which is benzene sulfonyl chloride, and benzene sulfonyl chloride is a primary amine reaction, and the product is formed N-methyl sulfonamide, N-methyl benzene sulfonamide. And if we take a secondary amine also, we get a product N-dimethyl benzene sulfonamide. So both primary and secondary amines react with Hinsberg's reagent. Then how to differentiate them? So the product form is again put in an alkali solution, NaOH. This is also NaOH. And if that PBT formed is soluble in that alkali, then the amine is primary amine, because in this product there is an acidic hydrogen. Due to the presence of this acidic hydrogen, this product formed will be soluble in an alkali. This is soluble due to the presence of acidic hydrogen and this will not be soluble because there is not an acidic hydrogen attached to this nitrogen. So due to absence of, you can say due to absence of acidic hydrogen. So if that product formed is not soluble in an alkali, then the amine has to be a secondary amine. For tertiary amine, there will be no reaction with Hinsberg's reagent. So this is very easy to identify for the tertiary amine. The next reaction of amine is very important reaction, that is electrophilic substitution reaction. In electrophilic substitution reaction of aniline, this NH2 group is a very strong electron withdrawing group and a very strong activating group. This is very strong electron donating group, not withdrawing group. Okay, this very strong electron donating group due to resonance, and since this is a very strong electron donating group, there will be excess of electron in the para and the ortho position. This is para position and this is ortho position. These two are ortho position. So there will be excess of electron in both ortho and para position due to resonance of NH2. And that resonance will be plus R. So let me give the examples of electrophilic substitution reaction. The first one is bromination. This is bromination. Bromination se aniline ga ikhoina bromine water ga reaction tawba matamdane we get 2,4,6-tribromoaniline as the product. In all ortho and para positions, bromine substitute. Now, why it is so? The one reason is the very strong electron donating nature of NH2, and another reason is bromine water is also a very good source of bromine. Bromine mayam thole aduga aniline dasu ortho and para position the electron charge mayam leireba ko aduna bromine ju mayam tholaga aduga ortho and para position the electron mayam am leirabni na every ortho and para position the bromine do tapak pui waneba ko. Now if we want to prepare only para bromoaniline from aniline, then what can we do? That is the next question, how to make para bromoaniline from aniline. These are the steps to be followed. First, we have to do acylation. This is acylation step. Okay. Okay, this is acylation step. Aniline is first reacted with acyl chloride or acetic anhydride. So an acyl group is attached here. This is CH3CO. Okay. So due to this acylation, the electron donating nature of NH2 or the plus R nature of NH2 is reduced to some extent. Therefore, the excess of electrons in all ortho and para position is reduced. So, but still this is an ortho para directing group. So next step is what? Bromination. In bromination, also to reduce the reactivity of the reaction, we take sulfur carbon disulfide instead of water. Okay, bromine carbon disulfide is taken in the bromination step, and into the para position of this N, bromine is attached. Since this NH is a para and ortho directing group. So sidai da acyl group taburise semak going to deki badarka lay. So to remove that acyl part, we need to do hydrolysis. The last step is hydrolysis. Nita dumsigi step kasi hang mane ko. Ado acylation to acylation to acyl group to hapsen ke bodoi khona my hydrolysis to ga desylation tare ha. Hydrolysis to ga sigi bond si khona thadat laga ko COCH3 do from the acetic acid ki form the lotokre, and this is NH2 and Br is attached to the bromo para position. Okay, this is how we can prepare para bromo aniline from aniline. Next important reaction is nitration. In the nitration of aniline with concentrated HNO3 and concentrated H2SO4, para-nitroaniline is obtained as major product along with meta-nitroaniline. These two will be our major products. Para-isomer is formed 51%, while meta-isomer is formed 47%, while ortho-isomer is only 2%. Then these two are our major product. Now two big questions arise here. The first one is why meta-nitroaniline is formed when this NH2, our NH2 is an ortho and the para directing group. Why meta-nitroaniline is formed when NH2 is ortho and the para directing group? The answer to this question is this NH2 reacts with HNO3. NH2 is Lewis base, H plus is Lewis acid. So acid-base reaction takes place before electrophilic substitution reaction. So to form this anilinium ion, NH3 plus, which is a very strong electron withdrawing group, and electron withdrawing groups are meta directing group. This is a meta directing group. Meta directing beta isomer si phangeba. Now again, second question is, if we want to prepare para-nitroaniline as the only major product from aniline, what can we do? That is, again, we have to do acylation. In acylation, instead of this acyl halide, we can also take acetic anhydride. Okay, so acylation of aniline takes place in a similar process. Then nitration step is done instead of bromination. Nitration step is to be done by reacting with concentrated H2SO4, and then to the para position of N, NO2 is attached. Then hydrolysis is to be done to cut out this acyl group to form this para-nitroaniline. These are the chemical reactions, some important chemical reactions of amine. Now there is again an important question which can be asked in your exam, that is Friedel-Crafts reactions, both alkylation and acylation. Friedel-Crafts alkylation and Friedel-Crafts acylation do not occur in aniline. Why? The reason is aniline is a Lewis base, while AlCl3 is a good Lewis acid. Aniline is a good Lewis base, while AlCl3 is a good Lewis base. This is Lewis base and this is our Lewis acid, Lb and La. Now this N donates electron to this Al to form this anilinium ion. Now NH2 plus, this is a very strong electron withdrawing group. Aduna benzene ring the electron excess oidre, benzene ring the electron kidore handagre. Benzene ring the electron kangre, you can say. Aduna benzene ring the electron kang abanina laitrabunina electrophile amana attack towning aroeba. Electrophile will attack only to that benzene ring which is in excess of electrons. Sidadi electron excess laibadi lairadna electron kangravani khaba kangre, you can say electron kangre ko. Electron dry oikre, electron rich oidre ko. Aduna maram oiraga electrophile alkylation da Friedel Crafts alkylation da CH3 plus lakani, Friedel Crafts acylation da CO CH3 plus lakane ba aduna moina tanna lak iba aduga sidana inthore iba CH plus laire inthokre na khallo ko electron lai tere haiba ko benzene the electron reach oidrabni na electron deficient orabna the electrophile would obviously not like to attack the benzene ring, means there will be no Friedel Crafts alkylation or acylation. Okay, now let us move to the next important part of this chapter, last part of the chapter, that is benzene diazonium salt. In benzene diazonium salt, this is the structure of benzene diazonium salt. Now preparation is from aniline by reacting with NaNO2 in presence of HCl, or we can take HNO2 in presence of NaCl to 73 to 275 Kelvin. This can be 0 to 5 degrees Celsius also. So aniline is converted into benzene diazonium salt. This is our aniline, and this reaction is called diazotization. Okay, chemical reactions of aniline I have written here. First, benzene diazonium salt is reacted with CuCl in presence of HCl. Chlorobenzene is formed, and if it is reacted with CuBr in presence of HBr, bromobenzene will be formed. And if it is reacted with CuCN in presence of KCN, cyanobenzene or benzonitrile will be formed. These are three different reactions I have written combinedly, and this reaction is called Sandmeyer's reaction, which is very important for council as well as CBSE board exam. And if we modify this reaction by Sandmeyer by taking copper powder instead of copper halide, this is copper halide, this is copper powder. Whenever a metal is written in a chemical reaction, that metal is in powdered form. So if the benzene diazonium salt is reacted with copper powder in presence of HCl or copper powder in presence of HBr, then chloro or bromobenzene is formed, and this reaction is called Gatterman reaction by Gatterman. Okay, and if benzene diazonium salt is reacted with Ki or NaI in presence of acetone, this iodine will substitute this diazonium group to form iodobenzene along with nitrogen gas. Okay, and if it is reacted with HbF4 and heated in presence of copper, then fluorine will attack and substitute this diazonium group to form fluorobenzene. These are the byproducts, nitrogen gas and the BF3 gas, and this reaction is called Bals-Kiemann reaction. Bals-Kiemann reaction. Okay. And if it is reacted, and if it is there is, for example, say if I take KNO2 here instead of copper, heating is done in presence of KNO2, then nitrobenzene is formed. Then here nitrobenzene will be formed. Okay, and this benzene diazonium salt reacts with water, and if it is heated at some low temperature or higher temperature, then OH will substitute this diazonium group to form phenol. and if it is reacted with H3PO2, hypophosphorus acid, or ethanol water can also be taken instead of H3PO2 to substitute this diazonium group by H to form benzene. These reactions, remember, these reactions are nucleophilic substitution reaction. These reactions are nucleophilic substitution reaction. Here the nucleophile is Cl minus. Here the nucleophile is Br minus. Br minus will easily attack this carbon atom of benzene to which nitrogen is attached, because this is a very strong electron withdrawing group. Therefore, this carbon is in electron deficiency state. So, weak nucleophile, even water is a weak nucleophile. This can easily attack this carbon atom. Okay. Now, these two are coupling reactions of benzene diazonium salt. When benzene diazonium salt is reacted with phenol in presence of a base, orange dye is formed. Benzene ga gi marakta N ani double bond ga loina samba ko sigise benzene dye orange dye haiduna kawi aduga benzene diazonium salt ka aniline ga reaction to honba in presence of an acid to form this yellow dye. Yellow dye the kamai to ba som the phenol gi OH se adum laigani ko phenol gi OH se challoi aniline gi NH2 se laigani ba ko yellow dye form to gane. And these two reactions is called coupling reaction of kanagi aniline gi, and this is one of the most frequently asked question in 12th council question. Okay, now these are some chemical reactions of aniline, of amines, and about benzene diazonium salt. And this is the end of this chapter. This is the second part of this chapter actually. Second part of chemical reactions of amines. Okay, let me end this video here. Please do subscribe to the channel and share this video to your friends. Thank you.